Good morning. My name is Morellec. I am a Master of Science student in Finance. Today, I will present my data science project called MOISE, which stands for Mood and Noise, a machine learning pipeline for comprehensive music analysis. Let me start by explaining why music analysis matters. The numbers speak for themselves. Spotify alone has over 700 million daily users. There are more than 100 million tracks available on streaming platforms, and the streaming industry generated $20 billion in revenue in 2025. This represents a massive opportunity. Digital streaming platforms generate unprecedented volumes of music data. This wealth of information enables computational analysis for recommendation systems, playlist curation, and cultural research. However, there is a significant challenge. Music is multidimensional. It combines audio signals, metadata, and lyrics. Human perception is subjective, and concepts like genre and mood exist on a continuous spectra rather than discrete categories. As the quote on this slide says, understanding music computationally requires bridging signal processing, machine learning, and psychology. This brings me to the 4 research questions that MOISE addresses. Question 1. Genre classification. Can we automatically identify music genres using audio features? Question 2. Popularity prediction. What makes a song popular? Can audio features predict commercial success? Question 3. Lyrics analysis. What emotions do lyrics convey? This involves NLP-based sentiment analysis and theme extraction. Question 4. Mood clustering. Can we group songs by mood? Here, I apply psychological theory to cluster emotional content. Each of these questions is addressed by a dedicated module in my pipeline. Now, let me present the project architecture. MOISE consists of 4 integrated modules. Module 1 handles genre classification using supervised learning, especially SVM, random forest, gradient boosting, and multi-layer perceptron. Module 2 tackles popularity prediction using regression models, linear, ridge, lasso, and random forest. Module 3 performs lyrics analysis using NLP techniques with text blob and NLTK. Module 4 applies mood clustering based on the circumplex model using k-means with k equals 4. As you can see on the bottom of this slide, the project comprises 8 parity modules, uses 3 datasets, generates 15 visualizations, and is accessible through a command line interface. The project uses 3 complementary datasets. First, GETSAN, the standard music information retrieval benchmark from Tsanetakis. It contains approximately 10,000 audio clips across 10 genres and 57 extracted features. Second, Spotify Top Songs. It contains over 6,500 songs with 13 audio metrics, including energy and valence, with stream count as our target variable. Third and finally, the Million Song datasets, which contains over 57,000 lyrics for NLP analysis, averaging 1,222 characters per song. For genre classification, I compared 4 different algorithms: random forest with 300 trees, SVM with RBF kernel and C equals 10, gradient boosting with 100 estimators, and a multi-layer perceptron with hidden layers of 115 neurons. Model selection used combined test accuracy and 5-fold cross-validation. For popularity prediction, I tested the linear regression as a baseline. Then I implemented ridge and lasso for regularization, random forest for nonlinear relationships, and finally gradient boosting with 100 estimators and a learning rate of 0.1. The target variable is log transfer stream counts. The lyrics analysis module implements a 4-step pipeline. Step 1 is sentiment analysis using text blob. This gives us polarity scores from -1 to +1 and subjectivity scores from 0 to 1. Step 2 is theme detection through keyword matching. I detected 8 different categories, which are love, life, party, sadness, dreams, freedom, happiness, and money. Step 3 is word frequency analysis after step word removal and text cleaning. Step 4 is a novel metric introduced, The personal pronoun ratio. This quantifies the lyrical intimacy by measuring how often words like I, me, you, and we appear in lyrics. On the right side of this slide, you can see the intimacy level distribution. 27.1% of the songs have high intimacy above 50%. 44.7% have median intimacy between 8 and 15%, and 28.2% have low intimacy below 8%. The mood clustering is grounded in psychological theory. The circumplex model, by Russell, represents emotions in two dimensions. The first one is valence, so positive emotion versus negative, and arousal, high versus low energy. I applied k-means with k equals 4 using 7 audio features: energy, valence, tempo, loudness, danceability, acousticness, and instrumentalness. The key finding is striking. Popular music strongly favors high energy content, while calm music is nearly absent from the charts. Before I show you the live demo, let me walk through the code architecture. The project follows a modular structure. In the source folder, we have separate files for the CLI, data loader, genre classifier, popularity predictor, lyrics analyzer, and mood clustering. The data folder contains the CSV files. The results folder is organized into figures, models, and reports. The implementations follow software engineering best practices: file type annotations for code clarity, NumPy style docstrings for documentation, multi-core parallelizations using njob equals -1, and models persistence via joblib serialization. The command line interface allows running the entire pipeline with a single command: python cli.py --all. Now, I'll show you what happens when I execute the complete pipeline. First, the genre classification module loads the JSON datasets with about 8,000 training samples across 10 genres. It trains on all 4 classifiers, reporting accuracy, precision, recall, and F1 scores for each one of them. SVM achieves the highest test accuracy at 91.34%, with cross-validation at 90.56%. The pipeline automatically selects it as the best model with a combined score of 90.96. The mood clustering module follows a 9-step process grounded in the circumplex model. It loads 6,513 songs and fits k-means with k equals 4. The results reveal our key findings. Quadrant 1, high energy positive or happy, comprises 43.2% of the song. Quadrant 2, high energy negative or angry tense, contains 39.5% of the songs. Quadrant 3, low energy negative or acoustic, which is sad or depressed music, represents 15.9% of the song. And most importantly, the last quadrant, low energy positive, which represents calm or peaceful music, only represents 1.4% of the songs. We can see that popular music strongly favors high energy content, while low energy positive music, like for example classical music, isn't very popular. The popularity module trains 5 regression models. Observe the L-squared values. Or below 5%, with random forest best at 4.38%. This itself is a significant finding, empirical confirmation that audio features alone cannot predict popularity. Marketing, artist reputation, and playlist placement dominate commercial success. The lyrics module processes 57,300 songs. Sentiment analysis reveals that 51% of the songs are positive, 39% of them are neutral, while only 9.6% of them are negative. The most common word love appears more than 91,000 times. The 2 most common themes are life, appearing in more than 75% of the songs, and in Love appearing in more than 66% of the songs. The average pronoun ratio that I'm going to show you here is only at 11.6%, indicating moderate in lyrical intimacy. The pipeline completes with 15 generated figures and saved trend models, all organized in the results directory. Now, let me summarize the 4 major results of this project. Result 1. Genre classification achieved 91.3% accuracy using SVM. This confirms that handcrafted audio features remain effective for genre classification tasks. Result 2. Popularity prediction achieved less than 5% error squared across all models. This is an important negative result. It demonstrates that audio features alone cannot predict commercial success. Other factors like marketing and playlist placement dominate. Result 3. Lyrics analysis showed that 51% of the songs have positive sentiment. Love and life are the dominant themes in popular music. And finally, result 4. Mood clustering reveals that only 1.4% of popular music falls in the calm quadrant. Mainstream music is heavily biased towards high energy content, both positive and negative. Now, I will discuss the contributions and limitations of this project. On the contributions side, first, I created a modular pipeline with documented, reproducible code that can be used for future research. Second, I provided empirical evidence that audio features are insufficient for predicting popularity. This is a useful finding for the research community. Third, I applied theoretical grounding from psychology, the circumplex model, to justify the choice of 4 mood clusters. Fourth, I introduced a novel intimacy metric based on personal pronoun ratios in lyrics. Now, on the limitations side. First, the genre module uses pre-extracted features rather than raw audio waveforms. Second, popularity prediction does not include social media or marketing features, which are likely the real drivers of success. Third, the 10-genre taxonomy is mutually exclusive, which does not reflect the reality that songs often span multiple genres. Fourth, the JSON dataset is from 2002 and is missing modern genres like EDM and K-pop. Looking ahead, there are 4 directions for future work. First, deep learning. Applying CNN and transformer architectures directly to spectrograms or raw audio waveforms would enable end-to-end learning without manual feature extraction. Second, social features. Incorporating social media metrics, release timing, and marketing data could significantly improve popularity prediction. Third, multi-label genres. Implementing multi-label classification would better handle songs that span multiple genres simultaneously. Fourth, modern datasets. Updating the analysis with contemporary music, including EDM subgenres, K-pop, and all recent releases, would make the results more relevant to today's music landscape. In conclusion, MOISE demonstrates that machine learning can effectively address multiple music analysis tasks within a united framework. Genre classification works well with 91% accuracy. However, this project also reveals important limitations, particularly that audio features alone cannot explain commercial success. The code is available on GitHub at github.com/paulmorellec/project MOISE. Thank you very much for your attention.